Hi, everyone. So my name is Avery. I am the senior talent manager here with Rangle. And I wanted to thank you guys all for coming out on this really hot evening. I know that it's really hot outside, so I'm not surprised that you guys all came inside to get away from the heat. So we have a really great speaker today. We have Wrangle's very own Seth Davenport joining us. He will be speaking on using Redux with Angular 2.
All right, so hi everyone. I'm Seth Davenport. I'm a senior software developer at Rangle.io. And today I'll be talking about Redux, which is an architectural framework, and specifically how to use it with Angular 2. This talk is actually originally given by my colleague Evan Schultz. He kindly let me borrow his slides and modify them and mess around, so this is my take on that topic. So most people who are working with Angular 2 or Angular 1 or React these days are building something called a single-page application. And they can get very complex, right? So these are applications that live in the browser, but they are essentially fully fledged applications. When you click around them, you're not reloading new HTML pages from the server like a traditional website. So there's a lot of logic, there's a lot of state. A lot of stuff that happens in the browser. And this is good in some ways. It gives you better user experience. It takes a lot of computation off the server, helps you scale a little bit better. But it does mean that you end up doing a lot of code in JavaScript, right? So you end up with these applications that have lots and lots and lots of parts. Oftentimes you end up in a situation where everything in your app is connected to everything else. Just by the way code sort of grows. It tends to grow organically over time. You'll find yourself in that situation that all developers love, which is, some urgent bug fix. You think, oh yeah, how hard can that be? You go in and you make a change and something completely unrelated starts breaking, and you're like, how the heck did that happen? So this is an issue that we all face as developers, right? Applications with their complexity, as the complexity grows, they don't scale very well. You'll find that it becomes progressively harder to add new features the more code that you've already got, and it just bogs you down. So then we start thinking about architectures, right? Are there clever approaches to structuring things that we can do to make this work better? And there's a few architectural ideas floating around in the JavaScript space right now. You'll hear people talking about component-oriented architecture, component-based UI. You'll hear people talking about unidirectional data flow, and what does that mean? And you'll hear people talking about statelessness. These are all ideas that have come out of, I think, largely out of the React community, but they're still very, very relevant for Angular developers as well. So let's kind of talk about what these things are, right? What is a stateless architecture? And why is it good? A lot of us were raised on object-oriented programming. That's been the dominant paradigm for the last 20 years, probably. Objects are examples of stateful constructs. You have an object, it represents a thing, it has some data attached to it, and has some operations for that data, all sort of neatly put together in a little bundle. Whenever you call an operation on an object, you can give it some arguments, and something will happen, right? But the thing that happens depends not only on the arguments you gave it, but on the state of that object at the time that you called it. So you can make the same call with the same arguments multiple times and get different behavior. And you can start to see the complexity here, right? There's a hidden thing that changes what you're doing at different times. And that thing is state. So this becomes very painful to test. If you want to test that object, it's not enough to just pull out the operations in isolation. You have to supply all that hidden state, all that hidden data that backs the object. Once you have thousands and thousands of these things in an application, it becomes very hard to reason about. I guess that famous quote about the two hard problems in computer science are naming things and cache synchronization. Well, if you have 100 objects, each with little chunks of state, that's really a cache synchronization problem with 100 levels. Why do we do this to ourselves, right? I mean, object-oriented programming was an idea that tried to help you think of your programs by analogy to things in the real world, by modeling them. And that's one of those ideas that on the surface seems to make a lot of sense until you actually do it. And then you realize that the real world is a very complicated place. And programs don't need to be that complicated. Why do we want to replicate all that messiness in our programs? So, there's an older paradigm in computer science from the 70s, the functional paradigm, which never, for whatever reason, never really got off the ground. I guess the languages that were dominant, that had the right tools at the right time, they tended not to be the functional ones. Until, really, JavaScript took off. JavaScript is not a functional language, but it has many of the constructs that enable you to use that style in it, if you choose. And so this is great. Some of these really clean ideas from the 70s are now suddenly possible in a place, the browser, where you can interact with things that are actually meaningful, as opposed to my previous experience with it, which was with sort of toy languages like MIT Scheme that don't really have any ecosystem around them. So, Redux is very much born of that philosophy, right? And the main construct of this whole architecture is the concept of a pure function. So we're dispensing with objects as our main building block, and we're going with pure functions. A pure function is simply a function that doesn't depend on anything outside of itself. It doesn't depend on any external state. You give it a set of arguments, it computes a value for you. If you give it that set of arguments 100 times, you will get that same value 100 times. There's no hidden conditions. There's no weird sort of state, influencing things. They have no side effects, right? They don't change things outside of themselves. They have no state. They don't rely on the context in which they're called. They're just called. And so they're much easier to understand. They're much easier to test. You don't have to really mock anything out. You just pass different parameters. And you can compose them. You can take a bunch of little functions, and you can write a function that combines those functions into a new, bigger function that does something more interesting. Functional programming has really kind of taken hold on the server side because it's very useful for situations where you have a database, and then it needs to be transformed into a response. And so you just do data, and then you do a bunch of functions on it, and then it comes out the way you want. So architectures like Redux are trying to bring that sort of philosophy to the front end. But let's talk a little bit about the dominant way of handling state in the SPA world right now. It's called Model View Controller, and essentially you'll have applications where the UI is built out of a bunch of little components, which makes sense. And typically those components are going to be backed by things called models. And models are just objects that contain the data that component is going to display, right? So the component affects a change to the model. You click on something, you modify something, you type something in, and the model ships that changed data back to the component and it displays it. I mean, that seems pretty simple. But like most things in computer science, what's simple when you have one of it becomes much less simple when you have many of it. And so Model View Controller, often results in this situation where you have a bunch of different components. They start only talking to their own models, but there's nothing to stop them from talking to other models. And pretty soon you have a twisted mess, right? Instead of, overshot myself, instead of a coherent architecture. And now you can start to see what we're talking about in terms of complexity, right? The number of connections between your components and your data is nonlinear here. So as your feature grows, your application grows, you're going to be adding different components, you're going to be adding different models. Adding each new feature doesn't add, 1 unit of complexity. it adds an amount of complexity that depends on the size of your previous code base. So a lot of people have started thinking about better ways of doing this. How do we control the number of those connections, essentially? How do we reduce them? How do we get to a situation where we add features and the complexity of the application grows linearly instead of exponentially? One popular paradigm that's come up, actually came out of Facebook, is called Flux. And it is based on the idea of unidirectional data flow. They basically looked at the state of two-way bindings between components and models, and they said, this is nonsense. This is the source of the problem. We're going to tightly restrict how data flows in their application. And so a typical Flux program has something called the dispatch loop. You click a button or you interact with a component, and what it does is it fires an action. And that action goes to something called a dispatcher, and that dispatcher basically broadcasts the action to anyone who cares about it. In this case, you have all your data. Instead of a whole bunch of models, you have a store whose only job is to listen to dispatches and then decide if it wants to update itself and how it wants to update itself. And having updated itself, it fires an event saying, I changed, and the UI can choose to re-render itself. So you no longer have a whole bunch of crossways connections between different pieces of data and your UI. There's only one way to change state. You have to fire an action. And the store decides how it's going to handle that action. So this is a very clean model. But we can do a little bit better. There's a variation of the Flux pattern, which is called Redux. People realize that if you're doing Flux in an optimal way, you typically just need one store. Because you're controlling the mutation in one spot at the dispatcher level, you don't need to have a whole bunch of little pieces of state in your application. You can have one place that just collects it all together. You can sort of think of it as a database on the client side. And changing that store is the job of a set of functions called reducers. And all reducers do is they listen to actions, and they decide how they're going to change the store for each action. So you might be wondering, if you have object-oriented habits, we've probably been told a million times that a single store of global state is probably a bad idea. But it turns out that it's not global state that's the problem. It's global mutation that's the problem. So the key element of React is that you can have a global read-only state, and as long as you very tightly control the people who can change it, you can reduce complexity in your applications quite a bit. And so the places that can places that can actually change the store are the reducers. So what does that mean? Well, you're probably familiar with the basic reduce function. If you've done any sort of collection-based programming in most languages, JavaScript is no different. Reduce in JavaScript is a function that is attached to array.prototype, and it takes a callback, and what it does is it iterates across a collection and progressively applies a computation to all of those elements. So the classic case of a reducer is a function that sums an array. If I can take a function that adds two numbers and I pass it to reduce, it will get called on those numbers progressively, and you will end up with the sum of all the items in the array. So essentially what we see here is that reduce is something that takes a collection and produces a single computation out of it. So Redux takes the same idea and it applies it to actions. All the things that you do in an application, you can think of them as a stream of events. They're basically a collection of things that happen over a period of time. And you can reduce over that collection. And if you do it right, the output or the result of the computation of reducing over all the previous actions in your life cycle is going to be the next state of the application. This turns out to be really powerful. You can describe any state of your application purely in terms of a set of actions that have happened in the past plus the next action. And actually, you can boil it down even further. You can describe it as the current state plus the next action equals the new state. And as soon as you have the state of your application, you can plug that into a pure render tree of UI components and get the current state of the UI. So typically what we'll do is, instead of having one great big reducer for your entire app, we'll split it up into little ones. And because they're pure functions, we can compose them together effectively into your application. I mean, so here's an example of a reducer function. So this comes from an application that my colleague Evan wrote. It's called Trendy Brunch. And you know, when you go into a restaurant and you talk to the person at the front desk, and they take your name and they go in a line, there's usually a piece of software there that manages who's in the line, who's seated at what table, orders, that kind of stuff. So this is not that application, but it could be. It essentially does that. And it's composed of a whole bunch of reducers for different data types. So one of the main sort of pieces of state that this application has to worry about is the lineup outside the restaurant door and who's in it and in what order they're in. And this reducer describes the interactions of that state in response to people's interactions with the software. So it's a pure function. You can see that it takes some parameters, it returns some state. It doesn't depend on anything outside its own closure. It doesn't depend on, you know, member variables or, you know, other services or things defined outside it. It is pure. And really, it's just a switch statement. It says, I'm going to listen to the stream of actions that happen in my application. And there could be 1,000 different types of action, but I only care about these three. I care about when somebody walks in the door, party joined. I care about when people decide they're fed up with waiting in line and leave, party left. I care about when a table becomes free and we move people from the line to a table. So those are the actions it cares about. It has an initial state, which is typically going to be an empty line. When somebody joins, it returns a new line with that person in it. When somebody leaves or when somebody's seated, it does the exact same thing. It returns a new lineup with that person removed, filtered out. So it's, you know, this reducer is only concerned about the lineup, right? Managing who's at a table is another reducer's job. And so this is the building block of our application's logic. The other thing to note about this reducer is that it doesn't actually mutate any objects, and I'll talk about that a little bit more later. We're not doing state.push because that's a mutation. That's non-pure. We're returning a new array with the person in it, and that becomes important for being able to insulate other parts of your application from the computations that you're doing, right? If we didn't do that, somebody else might be holding a reference to this parameter, and we would change it, and their computation would blow up. And this is the importance of pure functions, right? They encapsulate behavior. They encapsulate calculations. So the other nice thing about this, you know, it's a pure function, right? Testing it is easy. I don't have to mock anything. I don't have to isolate it from the rest of the application. It's just a function. I give it some parameters, and I check that the next state is what I thought it was going to be. You know, current state, an action, new state. This is a microcosm of our entire application. Because our application's logic is built out of this, testing the whole application is theoretically no more complicated than testing this one. This is an example of an architecture that scales linearly because the pieces are totally independent. But they're independent in terms of behavior, not in terms of state. So I think I already covered that. They're also synchronous, so you don't have to worry about promises or anything like that. Your data logic is 100% separated from your UI. It's, you know, your reducers worry about the action stream and what should be in the store next. They don't worry about rendering. They don't worry about any of the UI considerations. So your UI can be totally decoupled from your store. And you still have modularity, right? You can make a bunch of little reducers and compose them together. And finally, this business of thinking about your application as a pure function of your current state has some real interesting implications for tools, which I'll show later. So coming back to the reducer that I talked about not mutating the array that was passed in, right? So as a developer, when you're writing reducers, you have to be very careful not to mutate your arguments. And that takes discipline. It's very easy to make a mistake, and then your app is not behaving well, and you don't know why. We have what we do to insulate ourselves against that kind of mistake is we use something called an immutable data structure. An immutable data structure is an object that you can't change. So you create it, it has data, you can never change it. You can make a regular object immutable in JavaScript using object.freeze, although that's shallow. If you have child objects, it won't freeze those. There are ways, which I'll talk about later, to do a deep freeze. But then, of course, the obvious question is, well, come on, right? You can't never change your data. You'd have a program that never does anything. So what happens when you do need to change some state? Well, essentially, you will, instead of changing an existing object, you'll derive a new one, like what we did. Instead of doing array.push, we create a new array with the new data in it. And that way, anybody who has a reference to the old array doesn't get screwed, but you get the new data set that you want. So there's a library that will help you doing this called immutable.js. Adopting a naive copy on write strategy like I did a few slides ago will give you memory problems because you'll be creating a ton of copies of stuff and you'll have garbage collection churn. Immutable.js is a library that implements this sort of copy on write semantic in a much more clever, memory efficient way. I encourage you, if you're interested in knowing how, to look at the source code. It's actually pretty nifty. So, yeah, exactly. So what immutable.js will do for you is it will give you a construct called a map, which is analogous to an object literal. But you can't do, map dot foo equals whatever. You have to call a set function, and what it will do is will give you a new map with the new data. If you have a nested tree of objects, you can actually use it like a path of properties through it, which is also pretty handy. So this is going to be one of the key building blocks for our Redux-based stateless architecture. And actually, it plugs into Angular 2 really well in one specific way. Has anybody here played around with Angular 2's change detection strategies? Yeah. By default, what they'll do is the data that's in your controller, they'll compare all the fields of all the objects in order to figure out if something has changed. But if you can say to Angular, you know what, I'm special. I can guarantee to you that anytime I change something, you'll get a new reference to the entire object. Then you can turn on a special mode called onPush, where Angular will just check the references instead of all the properties. And this is a lot faster. So this is another benefit of the stateless architecture. So that's essentially what I just said. All right, so that was all, very theoretical and probably a little boring.
No.
So I guess let's get down to the nitty gritty of how to actually use this stuff. Redux is a library agnostic framework. It's written by a guy named Dan Abramov, who works for Facebook, and it's been heavily adopted in the React community. And I think most people think of it as a React idea, but it's actually not. It is framework agnostic, and there's no reason you can't use it in Angular 2. The React guys maintain a library called React Redux, which they describe as bindings between the Redux framework and React. Myself and my colleague Evan are primary maintainers of the equivalent thing for Angular 2, which is called ng2 Redux. It's actually one of two competing solutions. There's also another Redux-like library called NGRX, which does much the same thing. So, yep, Angular 2 bindings for Redux. You can find it at that location. I think we all know how to install things by now. What it does is it gives you a wrapped version of Redux exposed as an injectable service. So you can inject it into your Angular components. And it also will optionally let you access your store state by querying observables. And that plugs in very nicely to the way Angular renders itself. And it's compatible with the existing Redux ecosystem. Redux, at heart, what it does is it gives you the tools to make stores and reducers. But it also has these constructs called middlewares and enhancers, which people have done to sort of give you an aspect-oriented flavor of plugins that do various things, like persist your state to the browser local storage, or log every action change, or other sort of dev tools. So we are compatible with existing Redux middlewares. And that's the main difference between us and NGRX.
How about the Angular 1 plugin? Angular 1
Right.
Is it compatible? Do you know anything about it?
I'm not super familiar with that one.
Repeat it.
Oh, sorry. So the question was, how about the Redux adapter for Angular 1? I'm actually not super familiar with about it. But after the talk, I recommend that you talk to Evan in the back, who has actually done quite a bit of work on that particular connector. Sorry, Evan. Right, so once you've installed your ng Redux, you can just import it, and it's a provider like any other Angular service. So you can bootstrap your application with it. And then it's back to defining your reducers and composing them into your total application logic, your root reducer. And so this stuff is essentially the same as in pure Redux or React Redux. This is our lineup reducer from before. We have a few more similar functions for other pieces of data in the application, and then we're composing them into the top level reducer. If you are familiar with React Redux, the only sort of surprising thing here is that because Angular 2 is largely TypeScript, we're trying to be a little more aggressive with our typings than is sort of typical in a Babel workflow. Just because it's the Angular idiom. So once you've done this, you've basically defined your story, you've defined the types of all the data in it, you've defined the different records that you care about. How do I actually get that data into my UI? Oh, sorry, this is building the store. I glossed over that. So you're going to do this once in your app's top-level root component. And so the arguments here are the root reducer, any initial state you want from your store, and then any plugins, middleware, and enhancers that you're going to use. So now it's time to talk about the UI side of things. When we're writing SPAs, what we like to do is divide our UI components into two broad categories. The first one is we call the DOM component, or the presentational component. This is a simple stateless component that doesn't actually know about Redux. All it does is take some parameters and produce some DOM. That's all it does. If you're doing it right, 80 to 90% of your UI layer will be these things. So it's passed data down from a top-level component using Angular's input syntax. when you click on it or do stuff with it, it can emit events back up to its parent using Angular 2's output syntax. And it's just responsible for rendering. So here's a classic example of a dumb component. This is the thing that's going to render our lineup. I've omitted the template for brevity. It's on the next slide. But you can see that it just accepts some data, emits a couple events, and this class is trivial. I mean, it's a class because that's how Angular works, but we're not storing data in there. We're not keeping state in there. To do so would be the equivalent of using set state in React, which is an anti-pattern. It's just a place to define your parameters and your decorator. So this is actually a very declarative. It's probably the most declarative class I think I've ever seen. And that's the template. Once again, these things come from the inputs. Party ID number, party was one of the inputs. And this is one of the events being emitted. It's just an event emitter. So when you click this button, it emits an event with the current ID. So you'll have a pretty big render tree of things like this. And they'll all be orchestrated together at the top level by something called a container component. Container component does know about Redux. It is the place where data can come out of the store and flow into your UI. And it will take that data and will pass it down its render tree. It's also the one that dispatches the actions. Events bubble up to the top and it dispatches them. And so this is an example of a container component, mostly focusing on the template here. It's a little bit hard to read, but we're rendering a lineup component. We're passing in an observable that resolves to a lineup. I'll talk about that more later. And then in response to the lineup component's events, it is doing something which I'll talk more about later. So in order to hook this up to our store, we inject ng-redux. It allows us to do stuff. And then we can use the select API to get observables out of our store. So if I want to get the data that's associated with the lineup in our store, I can use the select call with the name of that property effectively, and this will create an observable which I can hook up to my UI. So that observable essentially is an event receiver, right? So anytime the lineup data changes in the store, my observable will fire. So that way I have hooked up this component now to whatever the current state of lineup is. But it's a one-way data flow. It's not a two-way binding. We have a bunch of different ways of selecting stuff. You can specify a property name. You can specify a function that will, transform the state that's coming out. And because it's an observable, you can use all of the different RxJS operators on it. Map, filter, reduce, combine, flat map, all that stuff. So if anyone here is familiar with reselect from the React ecosystem, this is sort of the ng2 answer to that, transforming data as it comes out of the store and goes into your UI. That's a little bit, it's kind of a lot of boilerplate. So we've also given you a shorthand in the form of a decorator, the @select decorator. This piece of code is doing exactly the same thing. If you call @select with no arguments, it will look for a store property with the name lineup, and it will create an observable on your class for you. Or you can be explicit about it. It's useful in the case where you want to name it something else in your class. Or you can specify a function. So I tend to prefer this this setup, but not everybody is comfortable with decorators because they're still technically an experimental feature. Although, if that changes, I think Angular 2 as a whole is in big trouble. So I don't expect it to change. So that's the getting data out of your store side of the dispatch loop. What about changing the store? So for that, we want to dispatch actions. So we'll use the ng-redux dispatch class, or function, which just essentially wraps Redux as dispatcher. Taking into account any middlewares that's been installed, etc. You can dispatch directly within your component, or you can make a service that does the dispatching, and I'll talk about both approaches. Doesn't really matter, because ng-redux is injectable, you can put it anywhere. And the things that you're dispatching, actions, are just plain JSON objects. They have a type and optionally a payload, and you want them to be plain JSON objects so they can be serialized. So here's an example of dispatching some stuff. This is our homepage. Let's say some people arrived, a party of people. We can have our template call party joined in response to a button click or whatever, and that will dispatch the party join action, which will cause reducers that care about that, in this case the lineup reducer, to add them to the store. I tend to put my actions in a service. It provides a few different benefits. If you need to use one of Angular's built-in services, you need to inject it into something so that you can access it. And you can only really inject it into components or other services. So that's one reason to create a service to put your action creators in. You can also inject ng-redux into it, so you can call get state. Sort of obviates the need for Redux thunk. Call the other stuff that ng-redux provides. So here's an example of a fairly trivial actions creator service. So it's a Angular service, injectable class. We're giving it information about ng-redux. We're, in this slide, giving it access to another service that we're not actually using. I should have checked that. But then it's just a function that just dispatches that plain JSON object that I was talking about before. If we wanted to do an asynchronous action, we can do that in our action creator. So for example, this is an example of an asynchronous action. Let's say there's some UI state between a party joining and it being sort of committed. This is how you would do it, right? You'd say, you'd dispatch an action saying, put something in a pending state, and then when your asynchronous thing is done, in this case it's a promise, you either dispatch an action saying, yeah, it worked correctly, or you dispatch an action saying, nope, there was a problem. This is a case where you definitely need to use an Angular 2 service, because in order to use party service, I need to inject it into my class. That's just how Angular 2 works. We tried for a long time to fight the anti-class war, but in the end, it's swimming upstream. Angular 2 is a class-based framework, and this turns out to be the cleanest way that I found of doing it. And this is what it would look like in your template. This is the other nice thing about an action service. I can inject it right into my class, and then I can just reference it directly from my template. And once again, I've gotten what I want, a trivial class that is just declarative. All right, so now it's time for a demo of an app actually of a reasonable amount of complexity that's been built with these ideas. So this is the trendy brunch app that we've been talking about, kindly put together by Evan with some edits from me. You can find it on GitHub. Yeah, and I will show it to you right now. And it's running. And there it is. So this is our app. We've got a little piece of UI to manage the lineup. Our restaurant here has 4 tables. And it has some inventory of stuff that they're able to serve. This is exactly the kind of application that would be kind of a nightmare to do with Model View Controller, because you're dealing with a small set of data, but it gets displayed in a ton of different ways in different parts of the UI. And if you were to use objects with copies of that data, trying to keep them in sync would be a nightmare. You would end up with situations where your stack of pancakes is, you've got 50 servings of pancakes in one location and you've got 49 somewhere else because something didn't propagate. Redux simplifies this all quite a bit, but I'll just give you an overview, I guess, of how this works. And I'm also going to show you some of the dev tools we have. So let's say some people arrive, 2 people. Let's say it's me and my wife. And we want to eat brunch. So the person at the front desk will enter us into the lineup. Later on, maybe 3 people will show up. I don't know. We can potentially have a ton of different people in line. So table, now we've also got 4 tables that are open, so yeah, let me assign somebody. Immediately, each of these drop-downs is kept up to date with the parties that could possibly sit at that table based on the table size and the party size. Right? So this is a 2-seater, so only the 2-person party can sit there. The rest, can easily accommodate 3 people. So even just here, I'm thinking, how would I do this with Model View Controller? How would I keep these menus in sync? As I change stuff, it would become quite annoying. I add another 2-person, and bang, it's already there. So that's one thing we can see. The other thing that we can see here is in the dev tools, I'm using a popular Redux middleware called Redux Logger, which will log every single action in the application. It will log the state of the application before the action was processed. It will log the details of the action. It will log the state of the application afterwards. This is super handy for debugging. There's one state, and you always know what it is at any point in time. So let's say I go to seat myself at this table. I can start an order. I can say I want a bunch of pancakes. You can see that the inventory is updating at the same time. Once again, this would be another annoying synchronization problem in MVC. When I've decided that I want my huge order, whoa. Fun. That's really cool. Right, let's pretend that didn't happen. I can still continue to update my stuff here, and everything stays in sync. If I seat another party, I don't have enough screen real estate here. Everything stays up to date. And we're still logging everything here. Another nifty thing that I'm doing is I'm using a third-party enhancer from the Redux ecosystem called persist state, which on every action serializes my store to local storage. So that's a big JSON blob, which basically is my store. So if I, reload my browser, it's all still there. That's another type of, that would be another level of synchronization that would be a pain in the butt to keep clean in an MVC architecture. And then finally, And this, to me, is the reason I kind of had my Redux epiphany. There is something called the Redux DevTools, and this is a Chrome extension. And it is amazing. Because your application is just a stream of actions, you can do some very interesting stuff. For example, let me make some changes here. You can actually rewind the state of your application and play it forward and backward. You can go into the action stream and you can cancel things. You can export the current state of your application as a blob of state changes. And this is super useful. You know, somebody finds a bug in the QA department. You say, open up your DevTools and export your current state. They give it to you. You load it up and you import it back into your application, and you can automatically reproduce exactly everything that they did. When I saw this, for the first time, it was, mind blown, right? Just the ability to play your application backwards.
It is meant for
Sorry?
Is this tool meant for
So this tool is meant for Redux, right? So you can use it with anything that's using Redux. So you can use it with React. You can use it with Angular 2. There are Redux dev tools that you can actually code into your application, but they're built with React. So if you're doing Angular, I don't recommend that because you'll have a bunch of extra dependencies. But this is those same tools packaged in a Chrome extension, so you don't have to change your code. It just plugs in with it. So let's take a quick look at the source code for this, if I can find it. Actually, to your question, I had to do some fiddling around to get the DevTools to work, but this is my application. I have it organized into containers, which are the smart components I talked about. I only have one, which is the home page. This is the full thing. Then we have all our presentational components, the thing that renders the lineup, the thing that renders the menu. These things are all very simple in terms of logic, just some input and output bindings. Templates are a little more complex. I'd be tempted to break these down even further, but I didn't have time. But the interesting stuff from our point of view is the Redux stuff, which is living in this thing called store. So every sort of functional area of my data store has its own little module, which consists of a reducer. It consists of some strongly typed stuff that I put in there, just to help me deal with things. I'm actually using immutable.js here, so I can do a state.push, but this isn't an array, this is an immutable list, so this will give me a new immutable list. On the other hand, because I'm using immutable, if I want to serialize stuff to the logger or to browser local storage, I have to write some transformers to do that for me. And then, as for the dev tools, the Chrome extension exposes them as a store enhancer, which I seem to have lost at the place where I actually use that. So I actually include them when I'm configuring my Redux store. But I've actually chosen to wrap that into an injectable service so that I can do it in Angular. And the reason I had to do that is Angular doesn't cope very well with events that come from outside the Angular zone. So you have to tell it that something external happened that it cared about. And the way to do that is using this appref.tick, which is an injectable service. So that's why I had to wrap that. I'm actually probably going to take this piece of code and actually roll it into ng2 Redux tonight or tomorrow, so you don't have to do it yourselves. But yeah, so that's a sort of an intro to doing Redux with Angular 2. And hopefully I've not bored you or confused you, and hopefully I've convinced you that MVC is the old way, and at least Flux and probably Redux is the new way. Subject to some caveats, which is that it's addictive, and once you wrap your head around it, you probably won't be happy with anything else, and your friends might not understand you. So thanks.